Alrighty, so today we're going to go ahead and talk about synthetic division. You have seen this before when in Math B we talked about it briefly just to give us some fun little work through, but we're going to use this more in Math C. So when we do synthetic division, we're taking a polynomial divided by another polynomial. So what we're going to do is attempt to reduce this polynomial to the next smallest exponent. So the first thing we want to look at is the way our first polynomial is written. We want to make sure it's in descending order. That means the biggest exponent all the way down to the smallest. So we have 2x to the fourth minus 15x squared minus 10x plus 5. So we're in descending order. That's great. Next we want to ask, is there any missing terms? So we want to go from one exponent to the next smallest one. So we have 2x to the fourth. Then I ask myself, do we have anything to the third power? No. So what I essentially have here is 2x to the fourth plus 0x cubed, because think about it, you have no x cubed term, but we are going to want one here in a moment, so we're just going to put in there 0, because anything times 0 is still 0. Minus 15x squared minus 10x plus 5. So the whole point of today is trying to divide based on using numbers. So we're dividing polynomials just using numbers, not using any exponents or variables. So now that we've rewritten our problem in order, what we're going to do is we're going to take a look back at what we're dividing by. So I didn't mean to go over that. We're dividing by x minus 3. So I'm going to go ahead and change that minus 3 into a plus. I'm going to do the opposite that I see. So I'm going to take that number and I'm going to put it into the coefficients. So this next part of the line is going to be all the coefficients of the terms that we just found. So we have the fourth term is a 2. That coefficient is the one in front. 0x cubes, negative 15x squareds, negative 10x, and positive 5. So we're going to do every single number. So we're going to go from the highest to the smallest power. And anything that is not given to us, we're going to substitute a 0 in its place, since it is there, but it's hiding. I'm going to draw my nice little line. I'm going to fix that negative 10. It's not the best. So that little line I drew over here is where my remainder part is. That means if there's anything left over from my division. So if you think about it, remainders are, say if I took 6 divided by 3, that gives me 2. I used everything up. But say 5 divided by 2 would give me 2.5. That 0.5 is that remainder, or something that's still left over. Okay, so when we do synthetic division, we're always just going to bring down the very first number. So I'm going to bring down that 2. Next, what I'm going to do is I'm going to multiply this 2 by the given 3. So 2 times 3 is 6. That's a positive. So I'm going to write plus 6 underneath my 0. This multiplication will help you figure out what you're going to do, either add or subtract to the next term. 0 plus 6 is 6. So I'm going to take 6 times 3, which gives me 18. So I'm going to write plus 18 under my negative 15. I'm going to add those two together. Negative 15 plus 18 gives me 3. I'm going to take 3 times 3, which gives me 9. Positive. I'm going to take negative 10 plus 9, which gives me negative 1. And I'm going to take negative 1 times 3, which gives me negative 3. 5 minus 3 will give me positive 2. So because we got a number in that spot, that means that it did not evenly divide out. So that means we have a remainder. So my answer here will be 2x cubed, because we started with a fourth. If I scroll up a second, we originally started with this fourth, so the whole point of synthetic division is to reduce our polynomial down to the next smallest exponent value. So we have 2x to the third plus 6x squared plus 3x minus 1 with a remainder of 2. So what that is saying is I divided my polynomials based on just the coefficients. So let's go ahead and take a look at the next one. First, I take a look, is everything in descending order? Do I have all pieces accounted for? Yes, it's in descending order. I have a cube, I have a square, I have a first, and I have a nothing, because remember, constants are nothing. So I'm going to divide by the opposite of this. So I'm going to divide by -2. My coefficient in front of that cube term is 1. Then I have 5 and 5 and -2. I will always, always, always bring down that first term, which will be 1. 1 times -2 gives me -2. 5 minus 2 gives me 3. 3 times -2 will give me -6. 5 minus 6 is -1. -1 times -2 is +2, which gives me a remainder of 0. Sorry, I forgot to throw that in there when I did my line, so I threw that in there quickly if you wondered why I put that little line in. It's because I forgot. Okay, so in this case we started with a cube term, so I'm going to end up with a squared term. So I have not 2x squared, I have just an x squared. Sorry, I said squared and I wrote 2. So I have 1x squared plus 3x minus 1. Now if I have a remainder 0, it'd be r 0, but I don't have anything left over, so I don't actually have to put it. So that's just my answer. Okay, so I'm going to start with the opposite of this. So instead of +4, I have -4. I look at my terms, everything's in descending. I have all of my things talked about, so let's go ahead and do my coefficients. So I have a 1 in the cube spot, a 1 in the squared spot, -10 in the x spot, and an 8 in the constant spot. First up first is I always bring down that very first number, so I get 1. 1 times -4 is -4. 1 minus 4 will give me -3. -3 times -4 is going to give me +12. So I'm going to add it. -10 plus 12 gives me 2. 2 times -4 gives me -8. 8 minus 8 gives me 0. So again, I have that remainder of 0. And my answer is x squared minus 3x plus 2. I think we're almost done here if I'm not mistaken. I think this is our last one. Yes, this is my last one. So I want you to pause it and try the video. Or excuse me, I want you to pause it and try this one on your own, and then come back and check your answer. So if you got your answer is 2x squared plus 9x minus 5, that is what you got. And that's all I have for you today.